Hello everyone, and thanks for watching my videos. In this video, today we're going to be looking into a very unique process. This process is the high temperature synthesis of advanced materials, in particular nickel aluminides, and it can be also used for titanium aluminide as well. So nickel aluminides and titanium aluminides, these are intermetallic alloys involving nickel and aluminum and titanium and aluminum. And without going through a lot of engineering details or material science and engineering details here, I would like just to introduce the process in the simplest term. So the process is literally a chemical reaction. That chemical reaction is a solid state chemical reaction. What I mean by solid state? I mean your starting materials are in solid forms. So you have a nickel powder reacting with aluminum powder. In this particular study, I started with nickel nanopowder as well as aluminum nanopowders. So the study was focusing on the behavior of starting with a nano size powders. So mixing these two powders in a turbulent mixer to basically have a homogeneous mixture, and then compacting that homogeneous mixture by a mechanical press. By compacting that homogeneous mixture by mechanical press to form what's called a green billet. A green billet is like, imagine your pizza the dough, that's basically considered green dough. You haven't cooked it yet. And then you're going to put it in the oven and you're going to cook your pizza and you're going to get your product. So the same thing here, that we have a green billet or a green compact. And that green billet or green compact is basically just a powder mixture between aluminum and nickel. Of course, the mixture is done in a specific ratio according to the chemical reaction. So if you want to obtain nickel aluminides, Ni3Al. So that's the outcome you want. You want Ni3Al, which means you need 3 moles of nickel versus 1 mole of aluminum. So your calculations is going to follow literally the general chemistry calculations. It's like how you do stoichiometry for a chemical reaction, which is I explained before in my previous videos. So anyway, so basically you mix the powders according to the chemical stoichiometry relationship. You engineer the density and you measure the density of the powder, and you engineer the porosity, how much porosity you want in your compact. You want to leave, again, you don't want to have 100% compact. You want to leave space for the process to take place and the expansion as a result of forming a product. So in this particular process, it's about 70% density. So the billet will have about 70% density of the powder. Then you put this green pellets in a furnace at around 700, 800 degrees Celsius. Once you put this pellets in the furnace, the billet, of course, is going to start heating up. And how the reaction takes place? This is a very interesting reaction because this reaction is also known as thermal explosion reaction. Because once the reaction is triggered, you're going to have this highly exothermic process, highly exothermic reaction. And you're going to see with in the video here shortly about what I'm talking about. But literally what you need to do is you need to basically heat it close to the melting point of aluminum, which is around 660 degrees Celsius. So as you are getting close to the melting point of aluminum, you're converting aluminum solid to aluminum liquid, and that help encapsulate the nickel powders and trigger the reaction at the ignition temperature. And you will see, in a minute or two, what I'm talking about. I just wanted to describe the process. So there is a clear vision about what this process is. And again, the importance of this process. Advanced materials are very unique materials. Their strength goes up as the temperature increases, which most alloys or most materials, as you increase the temperature, strength goes down. But these, again, intermetallics, they peak under strengths around 800, 850 degrees Celsius. So they're actually much stronger at higher temperature than steel. So, and they're being used in aerospace, engine components. And so, again, they're also known as intermetallic alloys. So without further ado, and I will stop my sharing about it here, and I will let you see for yourself what I'm talking about. Thank you for watching my video, and I'll see you in the next one.